Hello and welcome to the third Func Prog Sweden this year. First up, I would like to thank all recurring viewers. Thanks for coming back, and to all new viewers, welcome to Func Prog Sweden, the meetup and channel where we explore functional programming. So, over to the agenda of today. First, we'll have a short intro by me, Magnus, and then we'll have the presentation, Android Architecture Design with Koin by Arnaud. And after that presentation, we'll have the hobby scale, making web apps with minimal fuss by Martin. And then in the end, I'll go through the schedule and the summary of the meetup, and also announce the coming meetups. First, I would like to thank Odabeat, our video stream sponsor. Odabeat is a small but growing IT consultancy company based in Stockholm that also now have an office in Vietnam. Most people at Odabeat have a background in functional programming. If you want to know more about Odabeat, check them out in social media or on odabeat.com. If you want to support the channel or the meetup and the community, which you of course want to do, you head over to the meetup community and make sure to become a member. You subscribe to the channel. And if you really want to support the meetup group, then you can head over to the merchandise store at funkprogsweden.myspreadshop.net, where you can get a t-shirt like I have here, as you can see. Yes, and there are also more stuff if you want to. All the money goes straight back so we can make more meetups. If you have questions during the meetup or during the presentations, please ask them in the YouTube chat and we'll read them to the presenters so they can answer them. With that said, let's get started. First presentation, Arnaud. Welcome, Arnaud, to Func Prog Sweden.
Hi, Magnus.
Hello.
Hello. Happy to be here.
You're warm welcome. And we're super happy that we're finally having someone with Kotlin coming on and presenting for us. Thank you very much. Hit it away. The stage is yours.
Okay, thanks. Yeah, we talk about Kotlin language. It's really focused on Android architecture, but we see it's also, there's a part about multi-platform architecture for the mobile side then. But then let's go and for this Android architecture design with Koin. I'm Arnaud Giuliani. I'm the Koin project lead, the guy that created and is still working on these open source projects since 4 years now. I'm also a Google Dev expert in Kotlin. And you can also find me on Twitter, on this Twitter handle at Arnaud if you want. But let's talk about Koin and architecture today. Koin is in the latest version is in 3.15. This is the latest stable that you can update. And the next version, and we will see some of the feature today, is the 3.2.0. And it is already in beta. You can already play with it and enjoy a new feature around that. But let's go. And first, before talking about any architecture and stuff around, I would like just to share about what is Koin with the explanation of the core concept. And finally, when I have to explain what is Koin, I just say, yeah, just use Koin. It's easy then. But no. Koin, what is Koin is a dependency injection framework. That means it's a framework to let you configure all your dependency in your Kotlin application, and then you will figure out how you want to inject things together. And then if we have class A and B, what we want to do, what we'll give you is Koin is giving you a DSL here at the module section, where finally you are describing your stuff directly with the Kotlin language. That means it's a DSL that is compiling directly in your code as you are declaring a regular variable or something. But then the idea of the Koin DSL is to let you write your dependency directly with the DSL, and here call your constructor with the DSL. That means that here I will have to say to Koin that finally class A will resolve in class B, and here there's a little mistake here. Class B is resolving the stuff. That's okay. We will say that's okay. And you will have some constructor injection with the DSL. And then everything is built by your container. And if you want to retrieve instance in your API, you will use the inject and get API to unlock this, either with the Koin component interface. That means if you have a pure Kotlin application stuff, then a pure Kotlin application, you will just use inject and get, either with Koin component, either with a library that is already giving you the extension like Koin Android. That means that if you want to retrieve this dependency class B somewhere else, then you will have to ask your component to retrieve it. Just tag your class with the interface Koin component to allow you to inject this. And then you just make an instance of this class and resolve it by hand. Here, finally, the idea is to bootstrap your dependency. That means that it's not created directly by Koin, but more retrieve by Koin. And then finally, we use the Koin API to retrieve dependency. Either in the DSL, you are building pieces of your software and everything is built up by Koin. Here we are making really, let's say, a locator pattern usage here. Finally, just one thing is keep your Koin configuration simple. Less code equals less bugs. It's a chat as Google, well-known Google engineer that has these quotes, and I like that because this is also the way that we have developed Koin, is that finally we want really simple things, simple DSL to express things, and finally we want you to write really less code as much as we can. But let's dive into real application samples to really understand what we are doing today. And those samples will be found at those URLs, and I believe we will put it also in the resources on the video. It's based on Android architecture blueprints that is a application sample made by Google dev experts from Android and Kotlin, trying to demo some framework and some patterns. And here we will demo all MVVM and MVP patterns with Koin. One thing to see here is that in terms of Gradle dependency, if you want to use it in Android, you just have one dependency to use, that is Koin Android in the version that you want. But since Koin 3.x, you see that Stride dependency has been merged back in the main package. That means that you just use Koin Android and then you will gain access to everything else. Let's talk about the sample. Then it's a to-do application. It's really not super nice to see application, but it's a simple one that just lets you add to do. That means simple text things to, it's a list of to do to your list. And finally, what you will have here is something that is classical for Android. That means you will have an activity, task activity that is showing a task fragment. You will have a task view model that is dealing with your activity of fragment. Then your view model will try to retrieve data from the task repository. And the repository will deal with the data sources, either a remote one or a local one. And then in local way, we will use task database. in terms of component, we will see each component of this architecture, from the UI to the view model to all the other components of repository, data sources. We will see how they are written in this demo application, and we will see how we can configure it in Koin in just one line. Here, our first repository will help us access remote to do data. It's here, it's an object. That means it's already something that is already in singleton for Kotlin. It's a class that already has one instance, but then we can just reference it in Koin. In this line, we say single of the given type we want, and we in the lambda expression after that, we can express the way we build the class here, and then we build task remote data source. We specify directly a type next to the single keyword, because we want clearly to indicate here that we want just one type to be bound here. Then we have these data sources. If we have a single data sources in our application that is dealing with databases and other stuff, we will have the same type, task data source, that will be used by our repository, but then we want to make the difference between them. Then we will give some label, remote DS and local DS, that is here, two different implementation of the same task data source interface. And then we have in the first line task remote data source, and in the second one task local data source. And you see that finally we fill the constructor here with the get function of Koin DSL that indicates that we will resolve task DAO and IO dispatcher if you look at the class definition. And finally, what we have done here is that we declare the both task data sources here, and we give a different name here. It's quite readable, and then everyone understand finally what we are doing here. Let's go to our task repository, and finally how we can say to Koin that in our default task repository class here, we want to resolve firstly the remote data sources, secondly the local data sources, and then resolve other dependency. Here is how we do. We use the get function with inside the name function to indicate that we are using the right label for each of the data source here. This is important because then it's the way that finally we put label on different types. You see that finally in Koin it's super easy to define a type in your system, a singleton here, single of this type, and then a function to define here. And then we came to a database. We have repository, we have data sources. If you remind, the local data sources is using a database. It's Room, the Room database from Google. And here, what we can do also in terms of singleton is that we can declare something that is calling an API. We don't need to use directly a class. We can use directly an expression, because here we are, thanks to the DSL, we can run any line of Kotlin. And then what we will do here is build an instance of the database and then resolve the database to extract the task DAO. That means that the database instance can offer a function that is giving us the instance of the task DAO, and then we can give this reference to the other components behind. Then we have all the local data sources, the remote data sources, the repository. What we need now is our view models layer. This is the logical part just before the UI. And finally, what we want to do here is declare a Viewmodel instance. This class is really special to Android. It's extending the Viewmodel class here. And here in Koin, we have a special keyword Viewmodel to declare a Viewmodel instance, because then this instance will be hooked up in the lifecycle and Android, and then Koin will create the instance, and then your Android system will handle this instance for you. And the same as the other definition, we are just calling our class here and putting the get function to resolve the dependency. Finally, we are getting into the UI side. We have built up all the data side, the repository side, the database side. We have a view model that is ready to be injected in our task activity and task fragment. And with the magic of Koin, just a delegate function that is by view model allow you to have a lazy resolution of your view model instance, task view model here. It will allow to inject everything as well as the safe state handle that is a particular parameter from the lifecycle of Android. But then just keep in mind that finally the task fragment is not something that we can create directly by hand, and then it's called by the Android system, and then Koin can't create it for you. Then we will use a property delegate here directly to retrieve our dependency. If we are in MVP architecture, that means that instead of a view model logic component, you have a presenter component that finally help you to do another way of your logic. The way we are declaring it with a Koin will be just a factory. That means that we just create a new instance each time we are creating a task presenter. And what you can see here is that we are dealing with a real function. That means that each time the UI is triggering a new task presenter instance, then it will create a new one each time. Then it will follow your UI in a natural way. But also here, you can see that we have a parameter to pass to your function that is creating your task presenter. That means that we can pass arguments from the UI from the caller that is here, the UI, to your task presenter. Then you can have a reference in terms of contracts or other stuff for your presenter. That is quite interesting. And then just the factory keyword here. And finally, the regular keyword in Koin to inject things in a class that is having the Koin APIs is by inject. If you have just to keep in mind things is the Koin DSL, where you open a module section, declare things with single, factory, perhaps view model, and then once you have declared everything, you can inject in all your classes with the by inject expression. And by inject also can take a lambda to help you describe what you want to pass in terms of parameter. And then you have a parameters of here, a function that lets you give the reference of a parameter to inject in your graph and then inject into the final component here. Then finally, we have built up all our components, from the data to the repository to the view model, from presenter and UI. Then, yeah, we need to organize stuff around modules, layer, feature. Yeah, finally, what you can do is just organize yourself how you want. Yeah, Koin is here to give you really easy and comprehensive keys, but then it's up to you to organize yourself with module. That means that you just declare a module like a variable here, just a value here, and then you can combine all those modules together just with the plus operator on the module there. Up to you to split into layer, to feature, and organize yourself in the way you want to split, and allow you to test in the way you want. If we want to push the interest of the Android architecture a bit further with the clean architecture, that means that we will clearly dive a bit more into this domain aspect with interactor, entity, use case stuff. How we can see here this application that is having just task activity, view model, repository, and all the data components is finally, we can introduce a use case or an interactor here in the between your view model and your repository. And this is how we can finally handle it with Koin, is that you still get your view model like we were doing, but we change the dependency with the get task use case here. And finally, our use case will be just a factory of the get task use case class here that is resolving also is task repository. That means that your view model is creating its instance, is held by the Android lifecycle, is asking Koin for a get task use case instance. And finally, everything will be held for the entire Android lifecycle in a natural way, because your view model will just ask for your use case instance one time. Then it's really easy to finally create ephemeral components behind your view model just with a factory keyword. Let's wrap up, because we have seen many concepts and components, and finally, it's important to have the big picture in mind. This is our application. We have declared things for the presentation layer. We have declared things as Viewmodel presenter with factory or Viewmodel keyword. Every things below is declared as a single instance. That means that this is singletons. Okay, then in Koin, you just write single with the lambda expression of what you want to build here, then the task repository, local data source. And then we have built up everything. We have declared everything in Koin, from the factory to all the singletons. And then in the UI side, we just need to use the Koin API stuff. And if we introduce the use case component just behind the view model, we can introduce them as factory. The advantage of having factory instance at this level also is to ensure that we won't handle any state for the duration inside Koin. And then when the view model or the presenter is dropped, then your use case will be dropped also. Then this is the big picture of how we can declare things in Koin and how things are working. Let's go a bit deeper and go with the Android scopes topic. It's already a bit scaring topic, because finally it's always a bit tedious. And yeah, so the first question is, yeah, what's a scope? Scope is finally, for dependency injection framework, you can see as a space where we are maintaining instances for a duration of time. That means that it's not a singleton where finally is your instance are held forever. It's not factory that are just creating one time and they dropped out. Then it's somewhere finally where you want to use things for a certain duration of time. And after this time, we want to be sure that we want to garbage collect everything. Then why do we need some scope, especially in some SDK like Android and other runtime? What we want to do is be sure we are dealing with the same group of instance for the same duration of time. And then in Android, how it's going, then we want to be sure that this duration of time is completely compatible with the Android component lifecycle. We don't want to make memory leaks around here. Then if we think back about how we are building things without scope, just in a natural way, that means that if we have our UI or our activity here, just a my activity class that is super simple, we are injecting a presenter that is just defined as a factory here. What we will have here is that finally where configuration change is destroying your activity, then you will drop also your presenter. That means that your activity is created, you have one instance of my presenter, your activity is dropped, then your presenter is dropped. Then it's following naturally the life cycle. But finally, if you want to inject in the same area, you will need to specify that finally we hold instance in the same scope around my activity for the duration of my activity time then. And if we add something here, we add an extra component, my adapter here, that is using the presenter instance. If we want to be sure that my presenter, the presenter instance injected in my activity is the same as my adapter, we will need to use a scope. Then instead of using a classical activity, we can use scope activity of Koin. And then what we can do is in Koin, we declare just a section called scope of the given type, and then we declare everything we want in terms of scoped instance, and then everything will be kept for you in this scope instance. And then here, if we drop the activity, we also drop the scope, because finally the scope is dropped just after the destroy of the activity. It's not a view model. If a view model is a special component in Android that will survive to any death of your activity, and then with Koin you just declare it with a view model, and that's it. Finally, the same instance of view model will be held for the same after a new activity has been created. The new instance of my activity has been created. But one thing here is that finally, if we are using scope and view model, we may lead into a wrong life cycle. We will lead into a mixing life cycle. That means that we will have objects held in a scope, whereas the view model will be held in the Android life cycle system. Then it will hold your previous instance of my adapter and then provoke a leak here. What we can do instead, if we really want that finally you have to decide either you are using an activity or a fragment scope, either you want something that is surviving configuration changes like view model, then you have to be sure that your scope is configured to survive to this activity's default lifecycle behavior. And what we can do here is use the activity retain scope API here that is helping us create a scope that will be held as the same life cycle as a view model, and then we will have everything in the same life cycle. Getting access to the scope API in your activity can be done in two ways. Either you are using scope activity and everything is created for you, you just write by inject. Either you don't want to inherit from the scope activity from Koin and want to keep your class hierarchy, and then you are working on, you can just use the Android scope component interface to let you define your scope. You will have to define your scope here. Then we can have an activity scope, activity retain scope, or other kind of scope. But then you will manually deal with your scope, and then after that, you can write by inject in your activity, and then it will refer automatically with the right scope. Don't forget that finally, also, yeah, as I was saying, you also have the activity retain scope, the way that finally help you persist your instance through activities death. After that, we can also need to access some scope in a manual way. That means that there is other use case of scope, like if you are making an application that is dealing with wallet or stuff, or need to keep, let's say, data across several screens, then scope can be a good tools for you to hold instance between screens. You can get access to the scope API manually with getcoin.createScope or getScope. Then you will create scope and retrieve your scope with the given ID that you want here. And then you will pass everything in manual. Be sure to be careful because you can lose everything if you are not dealing carefully with your scope. Be sure to test everything down. One last thing about scope is a special one is the navigation graph. That means that some view model may be scoped to your navigation route. That means that it will survive. This will be the same view model instance for your application. How you can work with that, just use the Koin navigation components, declare your view model with the view model keyword here. And when you are injecting in and you want your view model to be persisted as a navigation graph view model, use the Koin nav graph view model function here with the idea of your navigation graph. And then everything will be okay for you. Yeah, scopes. I believe it's a hard topic, as I was saying. Let's wrap up a bit. Then how do you define a scope in Koin is just a section, a dedicated section for the given type where everything you are declaring components that will be held for this duration of time. Here we want to declare things inside the scope of my activity. You can avoid to use scopes if you are just using factories. You can, but then you won't be able to refer the same instance around in your components. To deal with this scope in your activity, just use the scope activity class or Android scope component interface. And then also to get the scope API, just get the static access getCoin, and then you will access to create scope, get scope, and everything that will allow you to resolve your dependency inside your scope instance. And lastly, don't forget the Koin nav graph view model function that lets you get the instance of your navigation graph view model. Yeah, heavy topic I was saying. Let's go with some more recent topic. And the first one is Jetpack Compose. Koin is proposing first API to let you inject your dependency inside Android Compose application. The idea is just to let you access your dependency in a natural way from your composable function. What you need here is just the Koin Android Compose package from Gradle, and then you will be able to get instance or your composable into composable function with just get or by inject if you want a lazy expression here. And also what can be done here is that inside your composable function, we have default parameter in Kotlin. Then you can also specify get here to resolve by default a dependency, but also that means that this composable can be reused. And then if you want to enforce another value of your dependency here, the my service parameter, then you can. Then you are not forced to use a Koin. It's just a default value. By default, you will use Koin in your composable function, but then it opens the road for you to let you inject other value if you want in test. The same way, we are proposing a Viewmodel instance with get Viewmodel and by Viewmodel expression, classical way to describe the thing. And then in the same approach, you can also specify default parameter value inside the composable function. If you want, we begin to play with the Jetpack Compose samples here, and we have a forked version of this Android GitHub repository, and here's the Compose samples, and we have one that is demoing how we inject dependency inside a Compose application. But today is clearly the first usage, and we want to explore more use case, more way to declare things in a composable function, and this will come later this year, I believe. Let's talk about dependency injection in the multi-platform world. Kotlin is a language that was mainly focused on the JVM and Android community, but today, not today, but since a while now, KMM, the Kotlin multi-platform, mobile multi-platform side of Kotlin, offer tools to let you really develop Kotlin with the Kotlin language, but for multiple platform in the mobile. Either the big picture for KMM is you can describe your logic with Kotlin and then inject it in your iOS application and Android application. The big picture around that is that finally you can still use your native UI code and use your library that is shared in common Kotlin code. Everything, presentation, business, data access, and then finally everything will be bound back to a native API for you. That is super interesting because finally you keep your native stack, your native UI code, and then you begin to work really with common shared library. I like to play with one of a well-known KMM sample application that is a people in space that is made by John O'Reilly. And you can find the repository here on the GitHubs of John O'Reilly on the John/people in space. And what is this application? Is a mobile application and several other, because he made desktop, he made web application in the same Kotlin repository. But then you see that we have the same purpose of iOS and Android application that is locating people in the ISS space station. And then how is it going? Finally, in the same workspace, we will have Kotlin code in the common part. We will have Android application. We will have iOS application. We can also have backend and web application. And how finally we are thinking about dependency injection. We begin to think about dependency injection in the common code. That means that finally we can design entirely our dependency injection in the common sources, and then we will be able to use those Kotlin Koin modules in the Android and the iOS application. How we can do that? Finally, we are describing a few common components like JSON serialization library instance, HTTP client, repository, remote access API, and a logger here. You can see several. Finally, we are declaring components that are purely Kotlin or KMM. And then, especially here for the HTTP part, we are using Ktor, and then we can configure Ktor for the multi-platform HTTP client part. Then finally, we can, as you see here, we are declaring everything in Kotlin and in a Koin module, as you see the function common module here. And then you will see that everything down that as I mentioned, is available to be injected in your application. And also we have a bit of part here is that as a Kotlin multi-platform side, there can have been some part that need to be explicitly written for each platform. And this is the case for SQLite configuration. That means that in this application, we are storing local database data. And what we will need to do is that we will need to declare a module, a dedicated Koin module for each of the instance. And you can declare everything in a common multi-platform module with Koin. But if you have native component, then you will need to declare it one by one. And this is how we have to do. This is the keyword expect that ask KMM to have a definition of something, and then you will have to give the implementation on each platform. And here is the extract on the IDE, where we see that finally platform modules is declined for common part, iOS part, GS, GVM, etc., etc. In Kotlin multi-platform, one of the main mechanism is having an expect function, expect contra, expecting things finally that has to be implemented in a native platform. And then you have expect keyword, and then you have also the actual keyword that lets you implement everything down. How we can do finally, we implement our module platform. We have in the common module expect fun platform module, and then in each implementation, we will have actual fun platform module, and then we will describe how we instance SQL delight for the given platform. Here we have GVM. It's the iOS side of the implementation with the right SQL driver. Finally, we have everything in the common space. Everything is ready in the common shared library, and everything is declared in Koin dependency module. And you will just have to declare things in your Android application or your iOS application to access your dependency. And this is quite magical, because finally you see that in the Android side, we just declare a Viewmodel instance, just one line here. We just ask the Viewmodel to retrieve the right dependency, and then that's it. Koin and Kotlin will make all the magic for you. This is the big picture to keep in mind. You can declare everything in the shared common code, Kotlin code, and then you can gather all these common Kotlin code with Koin modules. Yeah, it's almost the time and the end of my presentation, but I would like to share some new features that arrived lately, those months. And firstly, we have improved the new Koin DSL in 3.2 because there were one major pain of the community is having to write get everywhere in the function to resolve manually everything. Just as a reminder, it's because finally Kotlin here is a pure DSL and give you function to express stuff. Then we don't use any introspection, reflection, any kind of mechanism. Finally, Kotlin DSL is just running your function that is building your instance here. And what we have here is a new DSL, what we call constructor DSL, that finally will help you have a keyword, here is single off, and target directly your constructor with function, your constructor. That means that with the double colon character here before your class, you just write single off your class, and we will fill everything for you directly. You don't have to write function, you don't have to write anything else. Then it's super interesting because finally it gets rid of some really annoying code for us. How is it going? Finally, if we get back to some of the example I show you just before, we have a task data sources here that has a name, and we want to fill the task local data source class here with the constructor with get and get function. And with the new DSL, what we write instead is single off double colon character task local data source. We open a new DSL, and then we can write named and bind. This is clearly more readable and clearly more maintainable, as finally your DSL won't break every time you will change your constructor, and it will clearly more easy to read. Also, with simple definition like the view model, you will have a view model, and directly you can use your constructor view model, and then that's it. You're done. And the same with definition that are using injected parameter, we will handle everything for you. And then here we are using factory of, and then your constructor class directly here. We are keeping the same semantic DSL. You just add off at the end of the keyword, and then you can have the form with the constructor DSL. And then it's super interesting to use because it's still a DSL. It's still not using any kind of reflection. It's still it's filling everything in your constructor that will require a get function. Yeah, then in mind, same DSL keyword with plus of constructor classes. You will have all your default parameter of your injected param here, and you have options that can be filled by lambda, named and bind. I believe this is something that the community will enjoy, because when you have lots of configuration and you broke your one constructor, you change your constructor parameter, then you have to change your Koin configuration. Now you won't have to do it anymore. One another stuff that we introduce in Koin 3.2 is the modular key structure. Is that finally, instead of declaring each module one by one and having everything with the plus operator in between everything and having a list of modules, what we introduce is the concept of includes. Is that finally your module can include other modules. It may sound interesting, because it may sound really a standard usage, but finally, until now, people in Koin didn't have the real need of including anything. But now we can allow a module to include other modules, and it will help us clearly flatten everything for you and optimize the performance for you, and be sure that we load everything one time for you. And then we are flattening a complete module graph for you, and then performance are better. And then you can reuse the same included module in other module, to be sure that you are including the same stuff. Finally, if you write app module here, that is a Koin module you use includes, that is including other module. To start a Koin module, you will just have to start Koin with the app module, and then it will use the app module, the data module, and the UI module, and everything will be flattened down. That means that if you have another app module and you also includes data module, the same data module and UI module, we will have only one instance, and then we will organize everything for you and be sure that there will be no conflict. Another super interesting feature is finally the way that we are opening Koin to the way that we are declaring components inside. Finally, there is a thinking of we could go quicker in defining our components, and also we are limited by the possibility of DSL. That means that finally, the limits of DSL is that you can't analyze things for the developers. We can't understand, if we don't want to use introspection for performance purpose, then we can't analyze things in the DSL. It's really super hard to really understand the types and everything for you. Then this is one of a demand of the Koin community, is finally to open Koin to annotation here. And finally, can it be the dark side of Koin? Because Koin has always been DSL based, and DSL is the DNA of Koin. Not sure, because finally what we want to do here is to add another way to declare things for Koin, that finally more people will be likely to use Koin, and we will use the Kotlin compiler plugin capacity of Koin to help us get into everything for you. The real magic behind is KSP. It's the Google KSP project, where finally KSP, it's a project that helps you make Kotlin annotation at the Kotlin compilers level. That means that it's super fast. We can make really all the type analysis that we want, and then we can generate everything for you that we want. Quickly, I will show you how we would annotate everything with we will use annotation in the to-do application that we had together just before. Here you will use the Gradle dependency that can be used. You have to use Koin annotation and Koin KSP compiler with the KSP plugin. But I will give you the reference on the online startup project to help you start with KSP at the end of this presentation. Let's go back to our super shiny to-do application, and then let's go with defining everything in Koin. And instead of using DSL, what we will do is finally use annotation. And we will use the same semantic for people here, is that we want everything to be super easy and understandable quickly. That means that just tag your class with annotation, and then it will be registered in your Koin modules and application. Then here, we just use @single or data source. And finally, we have two data sources. Then if we want to make the difference between the two of them, we can add @named. It's giving a label on the application, on those classes. How we will do to declare the repository, we will use the @single on it. But then if we want to target clearly the right dependency, we just use the @named on the right parameter of your constructor. Be sure that here, when we tag your class, the class with @single or another keyword here, we are declaring the first constructor of your class here. We are detecting everything for you, and then we will generate Koin module DSL for you. Then super easy, because finally just write @single on the repository, @named in the label dependency, and that's it. In the view model, we just use the @Koin view model annotation, and then you're done. And finally, in the UI, things are not changing. Finally, we still use the by view model, and for task presenter here, we just use @factory, as we want this to be a factory instance. And if we want to mention that a parameter is an injected param, we will just use the @injected param annotation. And that's it. Finally, in our task fragment here, we will pass the right parameter, and everything will be done for you. Then we will want to use some modules. You can keep mixing both old DSL modules with this, but also we can declare this DSL side as a function, not as a function, as a class module instead of DSL directly. That means that we have class module to help you declare things inside function, that we annotate the class with @module. We annotate a function with @single, a function that will return the right instance of what we are creating here. That means that the parameter of your function, the argument of your function will be injected for you, and then you can build everything. And the same for the task DAO, we have in parameter here, the needed dependency, and then we can do the right thing. Then super simple in the same way that we have a class here, @module, to say this is a module, and @single on each function that will return a result of building a new instance here. Something that is super interesting here is that you can gather finally easily all your annotated components with the @component scan here. That means you will say we scan for all annotated component in the right package, and then we will gather all of these instances in this module. And finally, to start using this new class module, just create an instance of this class and then use the .module extension on it. This extension will be generated for you with KSP, and this is the only thing that is generated for you. That means that we can analyze everything, and finally we just write everything down for you, and then you are done. You don't need to do everything else. You can just play with the Koin API. You can mix DSL, everything down between DSL and class module, then up to you to use what you want here. And you can even use Koin without any module if you just want to use a default module here and just start directly with a simple application. It's super important for us to be clearly super fast at compilation time. That means that we are benchmarking our KSP compiler to be sure that for 1,000 components, it's really super small compilation time. And then for us, there is no pain to use this kind of this plugin in your project, because we try to give new solution against existing solution like Dagger that propose really stuff based on compilation and takes really lots and lots of time to compile. And then here we want to make the trade. We can analyze everything for you, but it has to be super fast. And then we don't need to generate lots of stuff, because finally, one annotation thing will be one line of declaration inside one module. Then it's super fast to generate, and then can be a super good tool for you on the super good tool. Also, one thing super interesting is that this generated code is Koin DSL. You can perfectly debug step by step inside this DSL module, and then that's it. Then yeah, that's it. It's Kotlin compiler plugin thanks to KSP. There is no we give to the community, really try to give tools for them. We try to give try to give the best that we can to help you declare things in Koin, either DSL if you want, or annotation, or you can mix if you want. Find everything about Koin annotation project in this on GitHub here on insertkoin.io/koin-annotations. First beta version has been launched. Then you can already play with Koin annotation, and then that's it. Finally, I'm getting at the end of my presentation. Next step with Koin. Just to give you a status of the current Koin version and how things are going. I know that lots of people and company are still in Koin 2.x. It's time to migrate, because it's a version that has started more than 2 years ago, and then you need to migrate because then we are beginning to clearly highlight support time for the community. Then please, if you are still in Koin 2.x, go with Koin 3.x to benefit from all the updates, all the critical patches, all the performance updates for you. And also, we need to be close to all the updates of your library, like Android library, like Kotlin language level, everything for you. Then be sure to update. Why we need to update? Because finally, we want to establish a clear roadmap in 2022. It's time to declare a real roadmap for Koin, and what we want to do is have a release cycle of 6 months for every minor version. Why? Because it allows us to have a really interesting time frame to give patches, to fix everything, and to follow in a really measured way all the updates of the community. Because Koin is injecting for Ktor, for Android, for Kotlin multi-platform, for Jetpack Compose, is using now key SP annotation processing. Then we are following lots of ecosystem. Then we need to be sure that we can update things in a really timely manner. And we want to master our versioning system. That means that we want, what has been done in the past is that some minor version and the fixed version has been mixed, then it could cause some problem. We really want here to have a good direction in our way to manage version, and then we will keep minor version up to date with fixed version behind to have fixed updates, and then we will just highlight all the features, the new minor feature with the minor version, etc., etc. We want to separate everything. Fixed version is just patch, minor version is deprecation and minor feature, and major version will bring you hard breakings. But then it's super easy to see if you can update easily or not in a Koin version. Then how it goes in terms of version in 2022, the active version is 3.1. The 3.1 version will be active for the community until Q1 and let's say start of Q2, because then we will start to run on Koin 3.2.x. Why? Because mainly we have important updates like Kotlin version. That means that Koin 3.1 is running Kotlin 1.5, and we can't run Kotlin 1.6 directly on the Koin version 3.1. Then we are running Koin 3.2 and following in September, in the end of the year, Koin 3.3 that will follow also the Kotlin ecosystem language lifecycle and the Android lifecycle also. Koin annotation will be stable. The target is Q2 of this year. And also what's really helped us really rethink about versioning and having active track, helping people to update, is that finally in terms of download volume, Koin was something downloaded between 5 million downloads in 2020, 9 million downloads in 2021, and now we have a good trend of 3 million downloads, at least 3 to 5 million downloads by month currently. Then currently the trends of download and usage of Koin is super impressive, and then there's more and more people using Koin, and then we need to be super strong in terms of versioning policy. But also, I'm also pleased to share with you about Codzilla, the company that is helping about Koin, making long-term support releases. That means that we will ensure extra time support for all the last active version for you. That means that instead of having just 6 months of active version, we will continue to work on version for extra 9 months on it. It's super important for people that are really making their business with Koin to be sure that finally Koin is supported for a long time. And also, sorry, having some consulting service to help you build the application around Koin and develop everything around Koin. Then to have some more information about Codzilla, you can find Codzilla on codzilla.io, also on Twitter, codzilla_io, and on LinkedIn. Then it's super important to have a real company to support Koin on the private side, and be sure that finally we keep the DNA of Koin as it. That means it's completely open source, sorry, and community driven. There's lots of people that still continue to contribute. You can find the documentation on insertcoin.io, the blog of the developers and Coin developers. And just a few URL for you. Documentation here, if you want to directly go to the reference documentation. If you want to start play with Coin, here is a URL to let you directly have a quick start sample application. And yeah, that's it for me. I believe we have seen lots of stuff today. It's time for coffee or beer. Depends on where you are. And that's it for me. Thank you.
Thank you very much, Arnaud. Very good presentation. I don't have any questions. I have a shout out, I guess, from one of your person that's downloaded it. Like, Koin is a delight. It has been a delight to use Koin.
Great.
Yes. However, I have some questions. How you came into Koin, and what's your take on it? When did you start using it and contributing?
Yeah, my story behind Koin is I've been starting using Kotlin since 2015, and in 2016, I started to put Kotlin everywhere. But in 2016, everything was really lots around Java ecosystem. Then for me, it was painful to not use the Kotlin language paradigms that we had here. Just a simple DSL to declare things quickly. And then it was one idea one day. And I began to publish the idea on GitHub and talk about that. And more people came to share this, help improve this idea. And then since 2017, yeah, this is the story of Koin, that is a little framework that is growing and helping building application around the world.
Really interesting. I think a lot of people have the same story, except you were able to get it to out to the world, actually. Yes. Yes. Do you have any? Do you have any known brands or companies that's using Koin at this point?
I don't know if I can talk about it, but I know in France there's some banks, there's some video streaming services, a big application that are using Koin in production. I was also working in UK, and in UK there are I seen many use of Koin also. Then and around the world there are lots of usage of Koin, and it's really in a very, very diverse category of application, mainly on Android, but step by step, I see that people are using KMM side, and we see many usage of multi-platform dependency injection with Koin. It's interesting to see this adoption increasing.
Yeah. Thank you very much. I don't see any more questions in the chat. Thank you very much for your presentation. It was really interesting. Thank you, Arnaud, again. Thanks.